Hi everybody, I'm Ali Tavakoli and this is part 4 of our UML tutorial series. In this part we're going to talk about class diagrams. So if you're ready, let's get started. Alright, class diagram. A collection of class diagrams represent the whole system. Classes in class diagram show different objects that are going to be used in our system and let us know how they relate to each other. Elements in class diagram are actually in abstract form and represent the blueprint. So a class diagram is actually a blueprint. Here is an example of a class diagram. In this example, I will explain more about OCL and its types and its rules. In this example, I will talk about what is a template class. This is a template class. And in this example, I will explain about different relationships that we have talked about them in the first part of our UML tutorial. But first, let's see for whom a class diagram is. Because a class diagram is a little bit more technical than the other first two diagrams that we have explained earlier, so it's good for only system designers and developers most of the time. What is its purpose? Describe responsibilities of a system. Important elements is class, obviously, relationships, such as inheritance, composition, aggregation, association, dependency, which we have explained all of these relationships in the first part of our tutorial. OCL, object constraint language, which is in three types, generally invariant, precondition and postcondition, and finally interface is the most important elements in this diagram. Points to consider. We can show multiplicity in classes. Multiplicity allows us to declare certain rules for our classes, attributes that are going to represent a group of objects. For example, animal class has owner's property that its type is owner class. So, owner's property is representing a group of owner objects. And also, our animal class can have at most 3 owners and they should be in order of ownership. So when we're representing this attribute, we can declare it like this. Our animal class has an private owner's attribute, which its type is owner, and it can be from 1 to 3 at most in the order of ownership. So this is its ordered, right? That's an example of a multiplicity and the setting rules for the attributes of our classes. Dependency and dependency and association relationships won't be shown in classes diagrams most of the times. Why? Because in reality, most of the classes have these relationships with each other, so we don't draw them in our diagrams to decrease unnecessary mess. What is a template class? A template or a parameterized class lets us to postpone the decision as to which classes the class is going to work with. I mean, we know that the class's attributes and operations will use another class, but we still don't know what type of that class might be. So, for example, a list class, it simply lists some items, but the class type of those items items vary according to different situations. I will explain it more when we go up there and seeing the template class practically. So what are the steps to draw a class diagram? Actually, drawing a class diagram is easy. We start drawing the base class, the very first class that will be initialized in our system. We actually draw it and then move on and draw dependent classes of the base class and then the associated classes of the base class. I mean, after that we have drawn the base class, the very first class that will be initialized in our system. The base class obviously has different attributes and is dependent on other classes. So then we will know that what other classes we should draw. We draw them and we continue and draw all of the dependent and associated classes of all other classes till we represent all of the needed classes for doing the responsibility that is needed for the piece of the project that we're drawing the diagram for. So you might now say that, wow, should I draw class diagrams for all of the classes in my project? Maybe my project is so much complex and is so huge. So shall I draw class diagrams for all of those classes? Well, no. By the end of the day, it's actually you who is going to decide which class diagrams is more important than the others. I mean, you may uh, only need to draw class diagrams for the most important classes in your project and not all of the classes. You know what I'm saying? Because some classes may be more important than the others, and those main classes are going to manage some other little classes. So you may only need to draw class diagrams for those classes. It is all up to you, and you are not forced to draw class diagrams for all of those hundreds or thousands of classes in your project. So obviously, it is you that decide to draw which class diagrams. So let's go back up here and explain our class diagrams in more details. In our example here, we're going to demonstrate two classes and an interface. This is an inheritance arrow, and this is an interface realization arrow. The person class has been inherited from the human abstract class, and the human abstract class implements the human interface. Let me first explain the person class. I have attached two nodes to my person class and have used OCL in these nodes, Object Constraint Language. In this first node, I have explained the precondition and I have used the precondition and postcondition type of the OCL, and in this node, I have used the invariant type of the OCL. Let me explain the first node. We are actually defining the rules for the work method of the person class. So our context is this. The work method of the person class, which has one argument, job, which its type is job, and the method doesn't return anything, so we write void here. The precondition that must be true so that the work method can be called is this. And the post condition that must be true after the work method has been executed is this. Let me first explain the precondition. The precondition actually states that the achievement attribute must be greater than or equal to 0 so that the work method actually can be called. And the post condition states that the achievement's value must go up by 1 so that we know that the work method has done what it's supposed to do correctly. And what do we mean by achievement at sign pre? We're actually referring the achievement's value at the pre-condition time. All right? Now let's take a look at our other note over here. In this note, we have used the invariant type of OCL, which must always be true. We're stating that self dot name, by self we mean the person class itself. And by name, we are actually referring to the name attribute. So the name attribute must not be empty. So we actually mean that the person's name attribute must always have a value. Now, let's take a look at our abstract human class. To demonstrate abstract classes in class diagrams, we should write the class name in italic form. So our abstract human class have these private variables, or let me say attributes, and these public operations, or in programming language we call them methods or public functions. And this is our interface, which actually states that the class that is going to implement it must have these three operations. And as we know, the notation of an interface is a circle, but we can also show it like this too, and express that it's actually an interface by using the interface stereotype. Okay, let's take a look at our next class diagram example. List class is a template class. Why? Because it has a parameterized type E. The list class is going to list some elements. What kind of elements? We don't know yet. So it has an attribute named elements, which its type is E. Now, the list of books class inherits the list class and binds the E parameter to the concrete book class. So, the list of books class defines exactly what is the type of the attribute elements. Its type is book, alright? Now, let's take a look at our other class diagram example over here. Our main class here is the classroom class, which has aggregation relationship with the chair because the classroom owns the chair class, and if the classroom is destroyed, chairs won't, and has a stronger relationship with the wall class, which is the composition relationship. And actually wall is part of the classroom, and if classroom is destroyed, wall will also. A classroom can have up to 20 chairs, but a chair is only for one classroom. And a classroom has 4 walls, but a wall is for only one classroom. And the classroom has a one-to-one relationship with the air conditioner. An air conditioner has one classroom, and a classroom has only one air conditioner. And that's all there is to the class diagram. And please don't forget to subscribe to our channel to be notified of our upcoming tutorials. So I will see you soon in the next part of the UML tutorial series. See you there.